I want to take kind of a step back today. I know a few of you guys had sent me some emails saying you're having a little bit of difficulty with the probability stuff. That is fine. We are in the last couple weeks of the school year. We're really in no rush to get through this. We don't really have a deadline or anything we have to meet. So we're going to kind of take a step back today and take a look at some single event stuff, and then we'll work our way back into the multiple event stuff we have been looking at. So, my pen working? There it is, okay. I think part of the problem too is the IXL stuff. So I uploaded the sheet, please kind of follow along. I'm going to go over the odd numbered questions, and you guys can do the even number questions on the first page tonight, and we'll go kind of through this. We'll probably pick and choose some of the questions we're going to do. So, single event probability. Of these names, one of these names is to be drawn from a hat. Determine each probability below. So if you notice, first of all, there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 names. So we're in 10 names. We're putting them all in a hat. We're going to draw one without looking. So what's the probability of pulling a certain example? So we're going to do the odd ones. Okay, so they told you, number one, what's the probability of pulling a 3-letter name? So how many 3-letter names? That's 4, that's 5. There's 1 3-letter name. No, 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 no. 2 3-letter names, right? Bob and Joe. So that is 2 out of 10 or 1 over 5 if you reduce it. We're going to take this step further. Let's also say if we wanted to, what is 2 out of 10? 2 out of 10 is going to be 0.2, or if we multiply it times 100, 20%. Okay, so if we wanted to, we could also write this as 0.2, which is equal to 20%. Okay, remember, to get the decimal, we're just going to divide the top number by the bottom number, and to get the percent, we're going to multiply by 100, right, per 100. Okay, so a name starting with B. So how many names up here do we have that start with B? Mary, no. Jenny, no. Bob, there's 1. Marilyn, no. Bill, there's 2. Jack, Jerry, Tina, Connie, and Joe. So again, just the 2 names that start with B, Bob and Bill. Okay, so what will we get? That is 2 out of the 10 names, which we established before is the same as saying 1 out of 5, which is 0.2, which is 20%. Okay? A 7-letter name. So how many 7-letter names do we got? Mary, no. Jenny's got 5. Bob's got 3. Marilyn, 1, 2, 3, 4, 5, 6, 7. There's 1. Bill, no. Jack, no. Jerry, no. Tina, no. Connie, 1, 2, 3, 4, 5, 6, no. And Joe, no. So Marilyn is the only 7-letter name up here. So what's your probability of pulling someone with a 7-letter name? That is 1 out of 10, which is, again, 0.1 or 10%. Again, if you're struggling a little bit with that, what do? You say, what's 1 divided by 10? It will tell you that's 1/10, right? It's 1/10. And then to get the percent, you're just going to multiply times 100. Right? Just take that answer and multiply it times 100. That's 10%. Okay? Our last one, let's find a name ending with Y. All right, well, we got Mary, Jenny, Jerry. Okay, so we got 3 of them, right? 3 of them end in Y. So that's 3 out of 10, which is 3/10, which is 30%. Again, you got that, that's 3 out of 10, which is 0.3, and 0.3 times 100. Oops, 0.3. Right clear, sorry. 0.3 times 100 will also give you 30%. Okay, so 3/10, 0.3, or 30%. Okay, if you get one of those, I'm totally fine with that. I don't necessarily need all 3. I'm just going to show you guys how to do all 3. All right, on the second page it says, one of these cards will be drawn without looking. So again, just a random thing. We've got letters, we've got numbers. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Something to watch out for, though, if you notice, we have some repeats, right? 10 occurs a couple of times, 4 occurs a couple of times. So right off the bat, we would expect that 10 and 4 are things that are more likely to come out. J occurs more than once, right? So these things are more likely because there's more 10s and 4s and J's than there are, say, a 9, which only appears once, okay? So again, what's your probability of getting a 5? Well, I've got 1, 2, 3, 4, 5, 6, oops. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I've got 12 total cards, right? And how many of them are a 5? Just the one, right? And this is where people can kind of get confused. This 5 has no value. It's just a character, okay? So we're not going to say 5 out of 12. We're just going to say 1 out of 12 because there's one card that's got a 5 on it here. So 1 out of 12, again, you break out your calculator if you want to change this into a decimal. 1 divided by 12, which is 0.083333 times 100. So 0.83 repeating. So we could say this is 0.083 repeating, which is 8.3%. Okay. Again, we're doing odds. So what's your probability of a number? So out of your 12 cards, I got 1, 2, 3, no, no, 4, 5, 6, no, 7, 8, no. So your probability of getting a number is 8 out of 12. If you'd like, you can reduce that, right? 4 goes into 8 2 times, and it goes into 12 3 times. And 2/3 is 0.666 repeating, which is 66.6%. So I can't fit a percent sign. 66.6 repeating percent. Okay, so 2 out of 3. So 2 out of 3 of the cards up there have numbers, which also conversely means that 1/3 of them have letters. Okay. Number 13, what's your probability of getting a T? Well, I don't have any T's, right? So what's your probability of pulling a T? It's 0 out of the 12 cards, which is 0, which is 0%. It's impossible. You can't pull a T because there's not one there. Okay? All right. Again, one card is drawn from a well-shuffled deck of 52 cards. So if you guys forgot, this is what a deck of 52 cards looks like. Okay, if you're not familiar with the deck of cards, that's okay. They can't even ask you about them on state tests, so it doesn't really matter, but they are a very handy way. If you guys remember when we talked about the original origins of probability, a lot of it has to do with card playing and games of chance, which are generally frowned upon, okay? But anyway, what's your probability of getting an ace? Well, they told you right off the bat, there's 52 cards in the decks, right? So it's right off the bat, this is out of 52. So what's your probability of pulling an ace? Well, how many aces do I have? I've got 1, 2, 3, 4. So that's 4 out of 52, which if we'd like to reduce is 1 out of 13. And again, that should kind of make sense, right? There's the same number of 1s, 2s, 3s, 4s, 5s, 6s, all the way up to kings, right? We have 1 out of each 13 suit. So here we kind of see that reduction pretty handily. So 1 out of 13. So 1 out of 13 is going to be 0.0769, we'll call it. 0.0769, which is a 7.69% chance of happening, okay? So not particularly good, but something to keep in mind. I know aces are always viewed as these very valuable cards, but you have the same chance of pulling as an ace as you do a 7, right? Less useful card in a lot of cases, okay? And what's your probability of pulling a red 10? So a red 10. So again, there's 52 cards in the deck. That didn't change. How many red 10s are there? Well, we have 2, right? We have the 10 of hearts, and we have the 10 of diamonds. So it's 2 out of 52, okay? Which again, if you reduce it, is 1 out of 26. Okay, 2 goes into 2 one time, 2 goes into 52 26 times. Again, what is that? 1 divided by 26 is 0.384, 0.0385, which is about 3.85%. And more importantly for us, what that means is there's actually, I know they don't look like it, but these numbers are half of one another, right? This number, if I multiply this number times 2, I will get this. It's half as much, right? So again, just something to keep in mind, right? Because again, here you had 4 out of 52, here you only had 2 out of 52. So these numbers are related, okay? Again, spinner, another common problem. So I'm just going to spin this like Wheel of Fortune. And we're going to say, hey, what's your probability of an even number? Well, there's 1, 2, 3, 4, 5, 6, 7, 8 numbers altogether. How many of them are even? I've got a 2, a 4, a 6, and an 8. So that's 4 out of 8, which is 1 out of 2, which is 0.5 or 50%, right? So again, I got a 50% chance of getting even or odd. And what that means is we have 2, 4, 6, 8. In other words, half my numbers are even and half of my numbers are odd. Okay? And your last one, tricky one, if you guys didn't get this, I'd be okay. What's a prime number, okay? So remember, prime numbers are something we've gone over. It's also a tricky definition, okay? 1 is not a prime number, so a lot of people will say that 1 is part of your answer. 1 is not a prime number. 2 is not a prime number. Oh, I'm sorry, my mistake. Let me cancel that. I'm sorry, I forgot my definition of a prime number, okay? So if you forgot what prime numbers are, a lot of what they say is that the only factors are 1 in itself, okay? But I will say by definition, the number 1 is not a prime number. If you guys want to know why, please ask, and I will gladly explain to you guys why 1 is not a prime number. 2 is a prime number, right? The only way to make 2 is 2 in itself. 3 is a prime number. 4 is not a prime number because I could say 4 times 1, or I could say 2 times 2. So 4 is not a prime number. 5 is a prime number. 6 is not, right? Because 6, okay, pretty much any even number besides 2, right? We could say, I could say 3 times 2 or 6 times 1. This is actually not the definition of a prime number, but for our uses, if you can remember that, that's fine. You just can remember that 1 is not a prime number. Okay? 7 is a prime number, 8 is not. So again, how many prime numbers do you have? You've got 2, 3, 5, and 7. 1, 2, 3, 4. So again, maybe I'll take a second tomorrow since we have some free time to explain why that is not, why 1 is not a prime number. It's kind of interesting. So more of trivia than anything, but if anyone ever asks you, 1 is not a prime number, okay? So I will talk to you guys later. Thank you very much, and we'll go after some more tomorrow.